So, right, well, I think we can probably get started. Let me go get up my script, and then... Yep, okay, ready. So,
Yeah, it seems fine apparently.
brilliant. Cool, well, yeah. So, welcome to CyberSoc. This is going to be our first session. I'm Harlan, I'm the president. Anyone else want to introduce themselves, or...?
Hello, I'm Michael, Vice President. I just woke up.
Hello, I'm Perry. I'm the treasurer for this year.
Does it Meg?
Matt?
Okay, Matt's not here. I am Meg. I am the events and sponsorship person.
I'm secretary.
What's your
He
name?
is Matt, by the way. The guy who didn't say his name, that's Matt the secretary.
Right, okay, so as you can see, we're very well organised. Yeah, I think we'll get started. So, Meg, off you go.
So, we're going to learn about OSINT today. So, what is OSINT? OSINT, or Open Source Intelligence, is gathering information from public sources. The main one, and the one we're going to be using today, is the internet, but it's anything that's publicly available, like newspapers, academic papers, anything you can get your hands on, you can use. Why do we do OSINT? So if you don't know what you're trying to attack, you can't attack it. It's as simple as that. And you could spend a bunch of money finding all the information out, but there's no point because there is so much data out there in the world for free because people are really careless about what they put out there. So I've just said people are careless. You might not agree with me. You think, no, we all know how to be safe online. You know, there are privacy settings that websites don't shut up about. We all know that our data is important and that if cybercriminals get access to it, they can do terrible things, and we've been making good passwords for years now. So, you know, people know how to be safe online. Yeah, people know. People know that if I have a picture of your house key, I can make a copy and I can have access to whatever you're trying to log. And there are definitely not thousands of pictures on Instagram alone of people's house keys. And people know that if I have access to your boarding pass, I can scan the barcode and find out everything about your flight. But people know not to do that. There's definitely not millions of pictures of boarding passes online. No. So you may think, okay, a very small fringe group of idiots put stuff like that out on the internet. But here is a news article about Tony Abbott, who, if you don't know, is a former Australian Prime Minister. And he put his boarding pass on Instagram and he got hacked. So, you know, people know how to be safe online, right? And then here's another news article about how a killer escaped jail by using a picture on the handbook of the master key for the prison because people really know how to be safe. So maybe people don't. Maybe people are dumb and they're ill-informed and they don't know what to do to protect themselves. So we need to know how to protect ourselves, others, and our organizations. And how do we do this? In cybersecurity, the best defense is a good offense. And these threats and attacks come in so many different shapes and sizes. And the best way to understand their impact and what they do is to understand the attacks themselves. And the easiest way to understand the attacks is to do them yourself. So you understand just how easy it is to use that data and find it, which is where Harlan comes in to tell you how to actually do OSINT.
Now, before I launch into this, I do need to give this disclaimer. Do not use this on anyone without consent from them, any individual, any organisation. This isn't just me saying this. This is literally stalking if you don't do it with their agreement. It's not very subtle either, and even a slightest slip-up in your OPSEC can cause it to be traced right back to you. It's also illegal. We're working with the university at the moment to try and get some form of rules of engagement, so maybe in the future we could have a look at doing security research with them. But until that happens, and until we publicly announce it, do not attempt to hack the university, please. Anyway, well, that out of the way, we can talk about robots.txt and sitemap.xml. So search engines, such as Google and Bing, crawl through the web downloading as much as they can to generate data for their modified PageRank algorithm, which is what they use to rank search results. However, most websites contain a lot of useless pages, metadata, and temporary resources, and other stuff that wouldn't be useful to the standard Googler. Luckily, we're not the standard Googler, so you can actually look through this stuff and find some stuff which might be of interest to you. So these two things, robots.txt and sitemap, Robots.txt asks the crawler to follow a set of rules about where it should and shouldn't go, but it doesn't force it to. It can choose to ignore it. And sitemap.xml gives it a sort of insight into the structure of the website so that it can cover it more completely. These are often automatically generated so that they can often leak a bit more information than the owner would have liked. They're also used in a bad attempt to hide poorly protected pages. But since they're in a public text document on the web, it doesn't actually make them harder and actually makes it easier for you to find them. You can often find this to find some interesting parts of the website that would have been hidden from standard users. And this attack may have been used against a senior member of Cybersoc in the past to get access to a collection of private notes. That's too far. Social media. So people post lots of things online, such as pet names, maiden names, even, with their grandparents, addresses, and their interests. Whilst a casual user doesn't really notice this wealth of information, if you're looking, you can probably find out a scary amount about someone. People and companies still use personal information as some form of security protection, which can easily be circumvented by even a brief perusal of their social media. Few people actually care about what they post online, because it all seems so harmless. I mean, why should you care about posting a nostalgic photo from your family's first home, or photo tagging your grandparents, and why should that cause a security compromise? To mitigate this damage, you should generally limit personal posts on social media to friends, and for filling out these security questions on websites, you should use random or unrelated text as the answer, whenever possible. Lots of the source code for things you can interact with are just published straight online. All JavaScript and HTML used on web pages is just completely publicly viewable. It's how web pages generate this stuff. This can often expose how the website works at a deeper level, allowing you to directly interact with the target, rather than going through the interfaces they want you to. Often these internal endpoints are far less secure, missing things like authentication checks, and even what IP you're coming from. We have a couple of sessions planned to talk about this, as this is something I've personally used to discover a number of critical security issues with a certain large organisation you may have heard of. With code also comes code comments. These are written in pretty much every single piece of code you've ever done. And it's absolutely hilarious when someone has commented out some useless code and that leads to a compromise. It's hilarious to everyone except the people who rely on that service for its security. You can find with these comments just insight into the development process of the software, old but still operational endpoints with vulnerabilities attached, secret tokens and passwords that shouldn't be public, and security measures that were disabled because they were deemed too difficult. Remember, all stuff on the web is basically public unless you completely protected it behind good authentication. Pictures. Pretty much all pictures have associated metadata in the file. This includes how it was taken, where it was taken, what it was taken with, when it was taken, and what version of the software is running. Off most modern social media sites, this metadata is stripped off, but not all of them, and for sort of file sharing websites, it just completely passes the file straight through. Until scarily recently, Instagram actually created a map with all the photo locations of a user tagged on it. This could be used to work out where someone lived, what school they went to, when they went places, if they were alone. It's not good stuff. So you can prevent this by disabling the location permission for your camera app, or turning off the relevant setting. And this isn't even talking about what people take photos of. People take photos of themselves, especially ones without much clothing on. If you don't take incriminating photos of yourself, they can't be leaked. Right? Keep that in mind before you do that. Pictures of keys that we saw earlier can be used to recreate the original, and it can go very badly. Often people will take photos of themselves outside their new house holding their key, a complete instruction manual on how to rob them. And of course, you get pictures of personal documents. These are boarding passes, driving licenses, tenancy agreements, many, many more, and they all contain a lot of personal information. often the barcodes on these things contain most of the information written in text, so it can be scanned by various authorities. And so if you want to not leak information, you need to also cover these up as well as the text. Or you could just post the whole thing on social media. As we saw earlier, we can just easily search through TripAdvisor or Instagram to get access to a vast wealth of personal documents, which nicely ties into Googling. Remember those crawlers from earlier? They're really good at getting information. Giant multi-billion-dollar companies spend vast amounts of effort making them great at getting information. So why not just use the work they've already done? There's a couple of examples on the screen of Google search tags you can use to refine your results. You can, if you don't care, you can find a bunch of templates online you can just copy and paste into Google for finding emails, domains, addresses, private keys, and much, much more. And there are services like Shodan that specialize in reconnaissance, using their crawlers to attempt to find hidden pages and domains. And that leads on to public records. These, on the internet, one of the central reasons for the internet was a central repository of all information, and unfortunately that's sort of what it's become. There's a good website is crt.sh. It's actually a security measure used to validate certificates, but as a side effect it lists pretty much every single valid HTTPS certificate you can get hold of. It's really good if you want to find a couple of hidden domains where they created an HTTPS certificate but haven't actually told you about the page. The way to get round this sort of reconnaissance is to use a wildcard certificate, which doesn't specify the exact domain, just says all subdomains. The solution is not to disable TLS. Please don't disable TLS on your websites. It's just not a good idea. The Wayback Machine and Google Caching Archives gives you a brilliant system for working out what pages look like in the past. If a page has gone down or they've fixed something in the page, you can look at how it was before using these services. And it's very difficult to get something taken off it. You have to go through a whole legal procedure, and most people don't even bother. There exist DNS servers that can be brute forced. These are the servers that actually define the domain name system throughout the internet. And you can see a little command here that allows you to brute force every single subdomain, off from a list for cybersoc.cf, our page. And this thing can run through thousands of candidates. If you write an optimized programs, you could quite possibly get it into millions. The DNS servers, in fact, are so good at being brute forced that it's actually used as a DDoS system, where you can just spam so much at them and redirect it to someone else. You can take out their servers. So as a result, if you spam a lot of stuff at DNS servers, you might get a knock on your door from the police. So be a bit careful with that. And of course, Git commits and objects do not go away. You probably have heard of Git. It's a source control system that pretty much everyone uses. When you delete a file, it's not deleted. It's stored in the history. If you delete a commit, you can often find it by manually browsing through the object store. If you accidentally upload a password or secret, or, like one of my friends did, an entire database, you need to just nuke the repository and start again, because there's so many ways of getting access to this data. It's just not worth trying to recover it. But yeah, that's enough talk for now. We've set up a CTF so you can actually put some of this stuff into practice without having to stalk a real person. We'll be in Discord to help you with it, so please drop in to chat to us. So visit ctf.cybersoc.cf to get to the CTF. Our Discord link is here. Please read the front page before you go into the CTF. It will tell you a couple of rules, such as if you start hacking people, we'll probably get very angry at you and might do shit about it. If we also have, you'll also see when you join, there's an OSINT challenge, which is to do with what we're doing today. There'll only be one challenge visible. Actually, when I bring it up, there'll be one challenge visible. You need to solve that before you can get access